Events enable an object to notify other objects when something of interest occurs. The object that raises the event is called the publisher, and the objects that handle the event are called subscribers. To demonstrate the use of events, let's first create the publisher. This will be a class that inherits from ArrayList, but this version will raise an event whenever an item is added to the list. Before we can create the event, we first need a delegate that will hold the subscribers. This could be any kind of delegate, but the standard design pattern is to use a void delegate that accepts two parameters. The first parameter specifies the source object of the event, and the second parameter is a type that either is or inherits from the system EventArgs class. This parameter usually contains the details of the event, but in this case we don't need to pass any event data, and so we just use the base EventArgs class itself as the parameter's type. With the delegate defined, we can create the event using the event keyword followed by our delegate and the name of the event. The event keyword is used to create a special kind of delegate that can only be invoked from within the class where it's declared. Its access level is public, so that other classes are allowed to subscribe to this event. The delegate that follows the event keyword is called an event delegate. In its place, we could alternatively have used the predefined system event handler delegate, which is identical to the one we have just defined. This predefined delegate is used by the .NET class libraries for creating events that have no event data. The name of the event is commonly a verb. In this case, the event will be raised after the item has been added, so we use the past tense of the verb add. If we created a pre-event instead, which is raised before the actual event, we would then use the ing form of the verb, in this case adding. Next, to invoke the event, we create an event caller. The naming convention for this method is to precede the event's name with the word on, which in this case becomes onAdded. The method has the protected access level to prevent it from being called from an unrelated class, and it is marked as virtual to allow deriving classes to override it. It takes the event arguments as its one parameter, which in this case is of the EventArgs type. The method will raise the event only if it is not null, that is, only if the event has any registered subscribers. To raise it, we pass the this_instance reference as the sender and the EventArgs object that was passed to the method. Now that we have an event and a method for calling it, we just need to override the ArrayList's add method to make it raise our event. In this overridden version of the method, we first call the base class's add method and store its result. We then raise the event with the onAdded method by passing the empty field in the EventArgs class, which represents an event with no data. And finally, we return the result to the caller. To test the publisher class, we'll create a new class that will subscribe to the event. This class contains an event handler, which is a method that has the same signature as the event delegate. The name of the handler is commonly the name of the event, followed by the event handler suffix. Next, we'll add a main method where we create objects of the publisher and subscriber classes. To register the handler in the subscriber object to the event in the publisher object, we just need to add the event handler as if the event was a delegate. Unlike a delegate, however, we may not call the event directly from outside of its containing class. Instead, the event can only be raised by the publisher, which in this case occurs when an item is added to that object.